Okay, so in order to do our next portion of our lesson, which is over writing out nuclear equations, we really need to make sure that first we know how to find the number of, really the atomic mass and the atomic number, which is going to be the number of protons. So that's what we're going to be focusing on for this portion of the lesson. So a few things here. We will represent atomic mass as the letter A. And atomic mass is going to be the number of protons and the number of neutrons. So essentially the nucleus of an atom, because that is where the majority of the mass of the atom resides, is in the protons, neutrons, or the nucleus. Okay, next we have the atomic number, which is going to be represented by letter Z. And this is going to be the number of protons. So the number of protons will determine what atom we have. Okay, so this determines which atom we have, which element we have, is what I should say. So the number of protons determines which element we have. Okay, now if we're dealing with a neutral atom, this will also be the number of electrons if we have a neutral atom. So remember, it's neutral. The number of positives are protons and the number of negatives are electrons. Should balance out. Neutrons, again, are neutral. Okay, but Z actually does represent specifically the number of protons, since that is the atomic number. Electrons have nothing to do with the atomic number. Okay, now we are looking at some examples here. Okay, so first example, we need to find out, we'll do this, uranium 238. Okay, so uranium 238, so we have here, and let me also clarify this, we have our A and Z will be written like this. So A again is our atomic mass, Z is our atomic number, X will be our element symbol. So we have 238, and then we have uranium here. I'm not going to give the atomic number because we can just find that on the periodic table. So we need to get familiar with using that. So we find uranium 238 is the atomic mass. It just so happens to match up with the one here on the periodic table. Uranium 238 is actually the most abundant form of uranium. So that's the most naturally occurring. It's the most abundant form. All right, so that is going to be the atomic mass written on the bottom. And then we have the atomic number written here. So that's going to be 92. Okay, so we have uranium 238, atomic number 92. So let's find the number of protons, neutrons, and electrons. So let's do protons first. Okay, so number of protons, that should be pretty easy. That's going to be the atomic number, since that is the number of protons. So that's 92. So 92 protons. Now electrons, since this is a neutral atom, it will be the same in this case. 92. Okay, let's do neutrons. Okay, so neutrons is going to be, remember, atomic mass is the number of protons and neutrons. We know the atomic mass. we know the number of protons, so let's use that to find the number of neutrons. So we're going to use this equation here. So atomic mass is going to equal the number of protons plus neutrons. So to find the number of neutrons, we're going to subtract the number of protons from both sides. So really, we're looking at the atomic mass minus the number of protons, which equals the number of neutrons. Or, in essence, we have A minus Z gives us our neutrons. Okay. So in this case, we're going to figure this out. So we have our atomic mass is 238 minus 92 is our atomic number. So we need to figure this out. So we're going to calculate what is 238 minus 92. And our answer is going to be 146. So 146 is our number of neutrons. It's as simple as that. And this is how we find the number of protons, electrons, and neutrons. So for us, we really need to look into the atomic mass and atomic number. This will come into play once we start writing out our alpha and beta decay chains. Number of electrons isn't going to matter a whole lot to us in this case, but we will be focusing more so on really the atomic mass and atomic number. But I wanted to show you guys how that ties into our next topic, which is going to be our nuclear equations. Okay.